Unit 1 Arranging Data to Convey Meaning. Presenting data in tables and charts. Hello learners, let's get started with Unit 1 from the course Statistical Quantitative Technique. The name of this unit is Arranging the Data to Convey Meaning. Presenting data in tables and charts. Here we will start with a brief understanding of statistical investigation, tabulation and chart. Let us begin this session. In any statistical investigation, the collected raw data is usually voluminous and unorganized. This chapter aims for arranging the data to convey meaning with classification, tabulation and graph in search of knowledge. Tables and charts are efficient tools for organizing the numbers. I repeat, tables and charts are efficient tools for organizing the numbers. Too often, however, the students and the quantitative analysis do not consider the order in which they present the data in tables or charts. This lack of our thought means that the sequence of items may not be compatible with author's objective, whether testing a hypothesis, describing a pattern or reporting data for others' use. The appropriate criteria for arranging the data in tables, charts often differ depending upon whether they are to be used primarily with or without proposed description. Tables or charts intended to present numbers as evidence to address a specific question or to accompany a description of pattern are usually the best organized so that they coordinate with that associate narrative. On the other hand, tables intended to present the data for reference use if structured so that the readers can find the numbers of interest to them with little written guidance. These two broad objectives suggest a very different consideration for organizing variables or response categories. In other words, statistics has to do with collection of data, example survey, presenting data, example charts and tables, and finally characterizing the data, example average, leading to data analysis for the purpose of decision making. In other words, statistics has to do with collecting data, for example survey, presenting data, maybe in the form of charts or in tables, and finally characterizing the data, example when you want to have average of all. So leading to data analysis for the purpose of decision making. Essentially, statistics or statistical method is a systematic way of dealing with the raw data or data set to extract meaningful information. What is meaningful depends upon the context. The study of statistics started with the method of finding the mean mode from the given data set. Later on, concepts like median, variance, standard deviation were added and method of determining them were developed. Still later on, when more information was required by business communities, like other concepts like quartiles, deciles, percentiles and skewness and kurtosis were added to repertoire of statistical methods. All these concepts put together give a set of values which is supposed to provide complete and essential information about the given data set. Notably, statistics can be individual pieces of information or study of data analysis. The term statistics can be singular or plural depending upon how it is used. Sports such as cricket, football, etc. have produced enormous amount of statistics that enthusiasts routinely pore over in the sports section of the paper. Statisticians have started to seriously analyze this data, determine the probability that team A beats team B in the World Series or determine which team will win. Serious application areas include actuaries, which require professional training in mathematics, statistics and economic techniques to put a financial value on future events. For example, what is risk that a 16-year-old in the Navi Mumbai area will have an auto accident in 2008? And what will be the average rupee amount to fix the damage be? How many people aged 40 to 65 will have heart attacks in 2015 and what will be their average claim be? How much money does a health insurance company need to set aside to pay for all the claims it will have in a given year? How much should hometowns pay for insurance? Actuaries can answer all for these questions and any other risk-based questions by building and running a statistical model. Students of management can find it immediate significance of statistical technique in the areas of accounting, management, finance, marketing, to name a few. Statistics is a need for accounting if you become an auditor. Statistics is needed for accounting if you become an auditor. As an auditor, you need to essentially test a company's financial records. And since it's impractical to go through absolutely everything, you need to pick a sample size that will give you a result at a certain confidence level. Similarly, other subjects in the management education in the respective areas may use appropriate statistical methods for different dimensions as it is evident from the tables. From the practical reasons, rather than compiling data for entire population, a chosen subset of population called a sample is generally studied. The data are then subjected to statistical analysis, which serves two related purposes: description and inference. Now let's see what is description and inference. Descriptive statistics can be used to summarize the data either numerically or graphically to describe the sample. Examples of numerical descriptors include the mean, standard variation or standard deviation for continuous data such as height, frequency, percentage of categorical data such as race. I repeat, descriptive statistics can be used to summarize the data either numerically or graphically to describe the sample. Examples of numerical descriptors include the mean, standard deviation for continuous data such as height, frequency, percentage for categorical data such as race. Descriptive statistics are used to describe the main features of collection of data in quantitative term. Descriptive statistics are distinguished from inductive statistics in that they aim to quantify summarized data set rather than being used to support statements about population that the data are thought to represent. So, descriptive statistics are distinguished from inductive statistics in that they aim to quantitatively summarize a data set rather than being used to support statements about the population that the data are thought to represent. Even when a data analysis draws its main conclusion using inductive statistical analysis, descriptive statistics are generally presented along with more formal analysis to give audience an overall sense of the data being analyzed. Some statistical summaries are especially common in descriptive analysis, which include examples from measures of central tendency, measure of dispersion, measure of association, crosstab, contingency table, histogram, quartile, scatter plot, to name a few. Now we are coming to inferential statistics. So far we discussed about statistical statistics. Now we are coming to inferential statistics. Inferential statistics is used to model patterns in data, accounting for randomness and drawing inference about a large population. These inferences may take the form of answers to yes or no questions, hypothesis testing, estimates of numerical characteristics, estimation, description of association, correlation, modeling of relationship, regression, extrapolation and interpolation. Other modeling techniques include ANOVA, time series and data mining. So now let us understand what is data. Data refers to graphs or images or particularly as a measurement or observation of a set of variables. I repeat, data refers to graphs or images particularly as measurement or observations of a set of variables. Data are often viewed at the lowest level of abstraction from which information and knowledge are derived. Data is collected in statistics for the following reasons. Obtain input to a research study, measure performance, assist in formulating decision alternatives, satisfy curiosity, and sometimes knowledge for sake of knowledge. For making correct graphical interpretation, which is followed by analysis of data, it is important to understand the scaling techniques used for collecting the data. That is, as data comes in various sizes and shapes, and it are important to know about these so that proper analysis can be used on the data. Usually 4 scales of measurement must be considered. Normal data. It is the result of normal scale which mean for making classification. Example, respondents classification as male, female. Respondents classification as male and female. Such normal data can be best represented by using bar chart and pie chart. In this case, it is important to keep in mind that the numbers do not have numerical implications. They are simply convenient labels. Ordinal data. It is based on ordinal data which may examine if an ordinal scale datum is less than or greater than any other value. That is, you can rank ordinal data, but you can't quantify difference between two ordinal variables. For example, preference scores are rating of eating establishment where 10 is good, 1 is poor. However, the difference between an establishment with a 10 ranking and 8 ranking cannot be quantified. It implies that ordinal data to be ordered where the difference between values are not important. Other examples may include Likert scale or ranking scale on a scale of 1, 2, 3, 4, 5 about your degree of satisfaction. Interval data. Such data are ordered with a constant scale but having no natural zero. Since height and weight etc. have a natural zero defined at no height, no weight, it makes sense to say that 2 centimeter is twice as large than 1 centimeter. On the other hand, year and temperature in terms of Celsius do not have a natural zero, which means the year 0 is arbitrary, and it is not sensible to say that the year 2000 is twice as old as the year 1000. Similarly, 0 degree is an arbitrary. Why picking freezing point of water? And it again does not make sense to say 20 degrees twice as hot as 10 degrees Celsius. Both these variables are interval scales. That means for interval data, difference makes sense but ratio do not. For example, 30 degree minus 20 degree or 20 degree is equal to 20 degree minus 10 degree. But 20 degree by 10 degree is not twice as hot. The fourth one is ratio data. Such data are stored with the constant scale having defined natural zero. Example, height, weight, age, length, etc. It is not meaningful to say that 10 meter is twice as long as 5 meter. The ratio holds true regardless of which scale of the object is being measured. And this because there is natural zero. Continuous data makes up rest of the numerical data. This type of data is usually associated with some sort of physical measurement. For example, height of the tree at a nursery. Is it possible for a tree to be 76.2 inches tall? Sure. How about 76.29? Yes. How about 76.2946563782? The possibility depends upon the accuracy of our measuring device. One general way to tell if the data is continuous is to ask yourself if it is possible for the data to take on values that are fractions or decimals. If your answer is yes, this usually will be a continuous data. So, before we finish, let us go for capping 4 scales of measurement in statistical data. First one is normal data. It is the result of normal scale which is meant for making classification. Example, respondents classification as male, female. Such nominal data can be represented as using bar chart or pie charts. In case, it is important to keep in mind that numbers do not have numeric implications. They are simply for convenience labels. Now, next comes ordinal data. It is based on ordinal scale which may examine if an ordinal scaled datum is less than or greater than the another value. That is, you can rank ordinal data, but you can't quantify the difference between two ordinal values. For example, preference score or rating of eating establishments where 10 is good, where 10 is good and 1 is poor. However, the difference between an establishment with 10 ranking and 8 ranking cannot be quantified. It implies that ordinal data is to be ordered, but the difference between values are not important. Other examples may include Likert scale of ranking on a scale of 1, 2, 3, 4, 5 about your degree of satisfaction. Interval data, such data are ordered with the constant scale having no natural zero. Since height, weight, etc. have a natural zero defined at no height, no weight, it makes sense to say that 2 centimeter is twice as large as 1 centimeter. On the other hand, here temperature 0 degrees Celsius, temperature in terms of 0 degrees Celsius, do not have natural zero, which means that here 0 is arbitrary and no sensible to say that year 2000 is twice as well as year 1000. Similarly, 0 degrees Celsius is arbitrary, and again it does not make sense to say 20 degrees Celsius is twice as hot as 10 degrees Celsius. Both these variables are interval scale. That means for interval data, differences make sense, but ratios do not. Final one is ratio data. Such data are stored with the constant scale having defined natural zero. Height, weight, length, etc. It is now measured to say 10 meters is twice as long as 5 meters. This ratio holds true regardless of which scale the object is measured, maybe in meters or in yards. This is because this is a natural data. Before wind up, let's have a small look into what is continuous data. Continuous data makes up the rest of numerical data. This type of data is usually associated with some sort of physical measurement. For example, height of the tree at a nursery. Okay, so it is possible for us to measure 76.2 inches, but not possible to measure 76.2914563782, because the possibility depends upon accuracy of measuring device. So, one general way out to tell if the data is continuous is to ask yourself if it is possible for the data to take values that are fractions or decimals, right? When you say yes, then it is a continuous data. Obviously, the diagrams, graphs are very common useful tools for visual display of information, but they have certain limitations for as enumerated below. Graphs and diagrams should not be treated as substitute for other forms of presentation. These may not be ideal choice under all circumstances. These depict only general idea of data and only limited and appropriate information. They are more appealing to the layman, but may not be for an analysis. These are subjective in nature, hence interpretations are different. Last one is for large number of observation, it is not easy and clear presentation in terms of graphs and diagrams. So finally we come to an end of this session. Thanks for watching this video.